So I'm going to go through the answers for the review packet for the Unit 11 test. And in starting with that, we're going to look at these problems here. And these involve looking at graphs. So remember, a limit is not what the value is, but it's the value of it's what you think the value is going to be. So as we look at this graph, as we approach from the left, we're getting closer and closer to a value of 3. But here, as we approach from the right, notice how this is trending towards 1. So because we're heading to 2 different points here, the limit does not exist. Make sure that I really emphasize that that is a letter D, not a letter O, or a number 0. Now here, as x is 2, we can see that y is 1. But as x approaches 2 from the left, we're approaching a value of 4. And same with the right. We're getting closer and closer to a value of 4. So the limit here is equal to 4. For number 3, same thing. We can see that the function actually exists at y equals 4. But as we approach from the left and from the right, the y value that it looks like the graph is going to be is at positive 1. So that's the value of the graph. Over here for number 4, we can see that as we approach this function from the left, we are approaching a y value of 1. Whereas as we approach from the right, we're approaching a y value of 2. Even though this function exists at the point x equals 2, because we're approaching 2 separate y values, yet again, the limit does not exist. Now for number 5, we can see that as we are approaching x equals 2 from the left, we're getting closer and closer to a y value of negative 1. And as we approach from the right, we're approaching that same point of negative 1. And so that is the limit there. Number 6, don't worry about number 6 for your test. This was an old sheet, and it's a problem that I'm not going to be asking you. So we will just ignore that. Now for the rest of these, we can actually plug in values or factor, and so that's what we are going to do. So if we look at number 7, we can plug in 1. If we plug in 1, we get 12 plus 1, which is 13, minus 1, which is 12. If we look at number 8, we can plug in negative 5, which gives us 3 times negative 6, which is negative 18. Number 9, if I plug this in, I get a 6 in the numerator and a 7 in the denominator. So these limits are nice in that I can just plug in the value that x is approaching, and I get the value of the limit. Unfortunately, for number 10, if I plug in the 3, I get a 0 in the denominator, which would mean the function is undefined. So what I can do is I can factor the numerator. And I can factor the numerator into x minus 3 times x minus 2. And because there's an x minus 3 in the denominator, I can factor this, cancel out the common factors, and I'm left with x minus 2. And so when I plug in a 3, I get 3 minus 2. So this is equal to 1. Same thing with number 11 here. If I plug in the number negative 7, I get a 0 in the denominator. But I could factor this to x plus 7 times, over x plus 7 times x minus 7. Now here, when I factor this, I'm left with 1 over x minus 7. And so when I plug in a negative 7, I get negative 1/14. Here, for number 12, if I factor out the greatest common factor in the numerator, I get x minus 2 times x. Well, the x's, again, cancel, and so I'm left with x minus 2. So I can plug in a negative 3, and negative 3 minus 2 is negative 5. Moving on, number 13 is a little bit weird because it looks like it's already factored, but we have this minus 36 there. So if I plug in 0 for x, I'm going to get undefined. So what's probably going to be best for me is if I multiply out this binomial squared and then simplify it down. So if I multiply that out, I get x squared minus 12x plus 36, and I still have that minus 36 over x. This reduces because the 36 minus 36 is 0, and the numerator has a greatest common factor of x. So I'm left with x times x minus 12 over x. The x's cancel out, and so 0 minus 12 is negative 12. Number 14, again, can be factored in the numerator. If I have this x plus 1 in the denominator, I'm also going to have x plus 1 in my numerator, and I'm going to have this 2x minus 3. And so the x plus 1's cancel. And so now I have 2x minus 3, which I plug in a negative 1 for. So I get negative 2 minus 3, which is negative 5. When I plug in 2 for x, I get 2 squared, which is 4, minus 2, which is 2, and I add another 2 to get positive 4. So I didn't need to factor or do anything there. It was not a fraction, so I didn't need to worry about a 0 in the denominator. Number 16 has a difference of 2 squares in the numerator, so I can factor that to x plus 1 times x minus 1 over x plus 1. The x plus 1's cancel, so I'm left with x minus 1. And if I plug in this negative 1, I get negative 1 minus 1, which is negative 2. And actually 17 is a duplicate of that problem, so that's also negative 2. And 18 is a duplicate of number 14, so that's also negative 5. Now for the remaining problems, we have these questions where we have asymptotes. So remember, if we can look at the asymptotes, then we will find where the limit is. So this first one, number 19, we can see that the degree in the numerator equals the degree in the denominator. So that means the horizontal asymptote is going to be at the quotient of the leading coefficients. So if this is 5 divided by 1, that's where the horizontal asymptote is, and that's also where the limit is. So the limit equals 5. Number 20, when the degree in the denominator is greater than the degree in the numerator, the horizontal asymptote is going to be at 0, so that's where the limit is. 21 is just in a reverse order. We can actually see that, that this is really the first term, that's the degree, and that's x. So if we divide negative 2 by 1, we get negative 2. And number 22 also has same degrees in the numerator and denominator. So 2 divided by 5 has a limit of 2/5. Now 23 has a degree in the numerator that's larger than the degree in the denominator. That means that my answer is either going to be positive infinity or negative infinity for the limit. So I have to think about what's actually happening here. Well, if I plug in positive infinity, I get a really large positive number. So let's think about some value here. What's a number that's close to infinity? Maybe a billion or a trillion? Well, if I plug in, let's say, a billion, I get a billion squared, and then I multiply that by 4. That's a really large positive value. And if I subtract 2 billion, it will still be positive. And if I add 3, just a drop in the bucket, it's still going to be positive. So my numerator is going to be positive. Likewise, my denominator is going to be 3 times a billion minus 1. Well, a positive number times a positive number is going to be a positive number. So it's a really large positive number, and I subtract 1, so it's still positive. So that means that a positive divided by a positive is a positive. So my limit is positive infinity. I'll skip 24 for now. I'll come back to that. But if I look at 25, this is the limit as x approaches negative infinity. And here, I know my answer again is going to be positive infinity or negative infinity. So I look at what the numerator and denominator are going to be. If I have a really large negative value and I cube it, it's still going to be negative. However, if I multiply that by a -3, that will then be positive. So this is going to be a really large positive value here that I subtract something from, and then subtract something from again, and subtract it again, but I'm not subtracting enough that it would be more than this value to the third power. So this numerator overall is going to be positive. Whereas my denominator, if I have a really large negative value and I square it, it's positive. But then if I multiply it by -2, it's back to being negative. So this is some really large negative value that if I subtract, because I have that same negative value times a +5, which is minus. So I'm going to have a really large negative value minus a large negative value, and that's just going to be more negative. Well, what happens when I divide a positive number by a negative number? I get negative infinity. Well, I get a negative value, therefore my answer must be negative infinity. Now 24, we can see that we have the same degree. So that means that if I divide 3 by 6, I get 1/2. And number 26, this isn't multiplied out, but if I multiply this, at least the first terms, I can see this is going to be 6x squared, and this is going to be 2x squared. So that means that they have the same degree. So I divide the leading coefficients, 6 divided by 2, to get my limit is equal to 3. Now for all of these, we can check by graphing, but we don't want to graph all of these because if this were a test and I had to plug all of these into a graphing calculator to graph, that would waste a lot of time. Whereas if I can remember these nice rules, especially for where x is approaching infinity, then that saves me time.